Hi everyone, it's your friendly neighborhood science teacher, and it is time for another lightning lesson. Today we're going to be working with 3 more equations. If you saw episode 3 in our force and energy series, you already know how to calculate for force using the equation F equals ma. We're going to be using 3 different equations to solve for more information. The first one that we are using is the calculation for work. We already know that energy is the ability to do work, so this is the equation that we use to calculate how much energy is being used or how much work is being done. That equation is W equals FD, or work is equal to force times distance. So we'll keep that over here in our equation bank so that we can reference it as we do some problems. Now, the reason we use this calculation is because when we have a force being applied and we know what distance it's covering, we want to know how much energy is being used. So we can use it in practice problems. Let's say we have a truck . The kind with a shovel on the front. This truck is pushing a mound of dirt. Let's even say we're trying to fill in a hole. So the truck is trying to push the dirt into the hole. We know that the distance being pushed is 5 meters, and we know that the truck is applying a force of 75 newtons. If we have this information, we can figure out how much work is being done. So our equation is W equals FD, which means work is equal to 75 newtons, newtons being our unit for force, times 5 meters, which is the unit we're using for distance. Go ahead and use your calculator to figure out 75 times 5. I'll give you a second to figure it out. If your final answer was 375, you would be correct, but we need a unit for this. We measure energy or work in joules, which we abbreviate as a J. Occasionally in problems, you will, instead of joules, see the unit Newton meters, which just comes from the 2 units that we're combining. So joules is what we usually use to calculate work or energy, but occasionally they'll put in the term Newton meters, especially if we're using this equation. This one's a pretty easy one to work with. If you need more help with problems, so for example, if you are doing problems that are missing force or missing distance instead, you can check out the F equals ma video for more information on how to rearrange that equation for the missing variable you have. Since W equals FD has the same format as F equals ma, you can apply the same mathematical principles to it to solve problems. Alright, the second equation we're going to be working with today is one that we can use to calculate potential energy due to gravity. Now, potential energy can be found with all types of energy, such as electric, light energy, sound energy, any of those types, but the equation we're using today specifically focuses on potential mechanical energy due to gravity, meaning that we're looking to calculate the amount of energy we would get if something fell from a certain height. So that's what this equation is specifically used for. That equation is PE equals mgh, or potential energy is equal to mass times gravity times height. Before we jump into actually doing the equation, I want to explain the units we're using first. So potential energy is going to be measured in joules, which is abbreviated as a J. So it's the same as the unit we use to calculate work. Mass for our purposes, is going to be in kilograms, or kg. Height is going to be in meters, which is in m. Now gravity. Gravity is not just a number by itself. The number that we use for this is the acceleration due to gravity. This number shows the rate at which an object accelerates if it is dropped. That number is always the same unless you are doing practice problems that are on a different planet. Since the acceleration due to gravity is always the same on Earth, we call that a constant. The acceleration due to gravity on Earth is 9.8 meters per second squared. And we use that number in all of our PE equals mgh calculations. A lot of times when you see practice problems with this equation, it won't give you the value for gravity because gravity is always the same for those practice problems. Again, the exception being if you are calculating potential energy due to gravity on a different planet, but we won't be worried about that right now. So let's do a practice problem. Again, our equation is PE equals mgh. Let's say we are trying to figure out how much potential energy there would be if a bell were to fall from a bell tower. So remember, it hasn't fallen yet, which is why it's potential energy instead of kinetic, but we want to figure out how much energy is stored in there if it were to fall. So this is our bell up in the bell tower. And we want to see how much energy it would have if it fell to the ground. Let's say the bell tower is 45 meters tall and the bell weighs 190 kilograms. We're going to use those values plus our value for gravity and put it into the equation. So PE equals mass, which is 190 kilograms, times gravity, which is 9.8 meters per second squared, times 45 meters, which is our height. So if you want to see that a little bit more clearly without those units, we're calculating 190 times 9.8 times 45. Take a second to figure that out on your calculator. You should get a really, really big number for this one. So our final answer is PE equals 83,790 joules. That's a lot of energy. It's a good thing we calculated that because now we know if this bell were to fall, this is how much energy would be behind that motion. And the final equation we are working with today is how to calculate kinetic energy. Again, this is mostly used for kinetic energy that is mechanical kinetic energy, so due to movement. But we're going to learn how to calculate that one next. So our equation is KE for kinetic energy equals 1/2 mass times velocity squared. So 1/2 mv2. I'll write it out again. KE equals 1/2 mass times velocity squared. Now, if you haven't seen exponents before, which are those little numbers next to the v, if we have a little 2 next to a value, that means we have to multiply it by itself. So before we jump into the whole equation, let's say my velocity is 5 meters per second. If I want to square it, I would multiply 5 times 5. I think of it as whatever this exponent is, that's how many times I multiply the value, so the number we have, by itself. So since there's 2, I multiply 5 times 5 to get 5 squared. 5 times 5. A dot can sometimes also be used as a multiplication symbol. All right, let's try an example. Let's say you are playing volleyball in gym class and you hit the volleyball. There's our volleyball. Our volleyball has a mass of 2.1 kilograms, and the ball leaves your hand with a speed of 30 meters per second. So it is traveling at a rate of 30 meters per second. We want to calculate how much kinetic energy the ball has. So our equation is Ke equals 1/2 mass, so 2.1. I'm going to put that in parentheses because those two numbers go together based on our equation. 1/2 times mass times velocity squared. So 30 is our velocity squared. Now another thing to keep in mind, if you're using a calculator, we can't actually type out 1/2. So you could do this one of two ways. You could do 0.5 times 2.1, because that's how you would type 1/2 into a calculator. We turn it into a decimal. Or you could divide 2.1 by 2 before you solve the rest of the problem. I'm going to choose to do it this way because that's easiest for me and that's what I prefer to do. But you can do it either way. So into the calculator, I'm typing 0.5 times 2.1 times 30 times 30, because remember we have that little exponent, which means we need to multiply 30 by itself. And that should give us our Ke. So go ahead and type that into your calculator. And we should get an answer of Ke equals 945 joules. And that's it. You can use the same method to solve practice problems for any of those values as long as you have the missing information you need to solve. I hope you found this video helpful, and I will see you in the next one. Bye!